Welcome to This Explainer. If we stop and really think about it for a second, human flight is practically modern magic. Today, we're taking a deep dive into the very first chapter of the Principles of Flight. We're going to break down the fundamental physics, the core definitions, and basically the whole shebang that makes aviation possible. So let's just dive right in and decode this absolute masterpiece of engineering that lets us conquer the skies.
Genuinely ponder this for a second. How on earth does a machine constructed of heavy metals, loaded up with cargo, jet fuel, and passengers, sometimes weighing hundreds of thousands of pounds, just stay suspended in thin air? It completely defies our everyday, earthbound intuition, right? If you drop a rock, it falls. So why doesn't a Boeing 747? Well, the answer lies in a really beautiful, invisible battle of physical forces.
So, here's our flight plan for today. First, the anatomy of an airplane. Then we'll look at the four main forces: the force of weight, defying gravity with lift, and thrust and drag. And finally, we'll see exactly why an aircraft is a masterpiece of compromise. Let's get to it.
All right, Section 1, Anatomy of an Airplane, the Engineer's Blueprint. Think of this as building an airplane from the ground up. There are 5 primary, absolutely non-negotiable requirements that every single aircraft has to have. First, a wing to generate a lift force. Second, a fuselage to house the payload. That's you, me, and all our luggage. Third, tail surfaces to add some much-needed stability. Fourth, control surfaces so we can actually change the direction of flight. And fifth, engines to make the whole thing go forward. Every plane you've ever flown on is really just a variation of those 5 basic ingredients.
And when you look at different structural blueprints, it becomes pretty obvious. Whether you're looking at a massive commercial jet or a tiny little crop duster, no matter how radically the designs vary to suit their specific missions, they all incorporate those exact same 5 physical requirements. You might see different sizes, weird engine placements, or completely different tail shapes, but the underlying mechanics, they're universal. The hardware changes shape, but the blueprint stays exactly the same.
Moving right along to Section 2, the force of weight. Grounded reality.
Okay, before we even talk about weight, we really need to lock down a crucial definition, and that's mass. Simply put, mass is the quantity of matter in a body, usually measured in kilograms. But more practically speaking, it's a measure of how difficult it is to start or stop that body from moving. An airplane obviously has an enormous amount of mass, which means it takes a huge amount of energy to get it rolling and an equally massive amount of energy to bring it to a stop.
Now, because an airplane has all that mass, it is constantly subject to gravity. That interaction creates a force, its weight, which acts vertically downward at all times. And honestly, until we do something to counter that downward pull, this magnificent multi-million-dollar machine is literally nothing more than a very expensive paperweight sitting on the tarmac.
Which brings us to Section 3, defying gravity with lift, the upward push. To actually get that plane off the ground, that downward force of weight has to be perfectly balanced by an upward force, and we call that force lift. This lift force has to be actively increased until it perfectly matches the airplane's weight. The very split second that lift exceeds weight, boom, we're airborne.
Next up, Section 4, Thrust and Drag, the forward battle.
But wait, how exactly do we get those wings to generate that upward lift in the first place? Wings don't just sit there and magically create lift out of thin air, right? They need air rushing over them. To generate a lift force, the airplane has to be propelled forward. This forward push is a force called thrust, and it's provided by the engines. Thrust is the enabler here. It pulls the aircraft forward, slicing the wing through the air so it can push us up.
But hey, nature never gives us a free lunch. From the very second that airplane starts moving forward, the air pushes back. It resists that motion. This resistance is called drag. So now we've got the complete picture. Weight pulling us down, lift pulling us up, thrust pulling us forward, and drag pulling us backward. It's a constant 4-way tug of war.
So you might be wondering, what happens when all 4 of these forces are just battling it out? Well, in straight and level flight, the aircraft enters a pretty amazing state called equilibrium. This is a condition where the sum of all moments and forces acting on a body is exactly 0. That means lift perfectly equals weight and thrust perfectly equals drag. The aircraft isn't accelerating up, down, or forward. It's in perfect, stable harmony. It is a brilliant mathematical balancing act playing out right there in the sky.
Now, we really need to break our earthbound biases here for a second. Think about a car. A car physically grips the solid road to move and turn, But an airplane, it doesn't grip the air at all. An airplane interacts with a fluid because remember, in physics, a gas, like our atmosphere, is actually considered a fluid. And because it's moving through this constantly shifting three-dimensional fluid, an airplane is often not even pointing in the exact same direction that it's moving. It's drifting, it's sliding, it's literally carving its way through the sky.
And finally, Section 5, a masterpiece of compromise, the domino effect.
Because this machine is swimming through a fluid environment while juggling those four opposing forces, things get complicated real fast. These forces exist in a sort of cascading domino effect. Let's say you want to carry more cargo. Well, more cargo means greater weight. Greater weight means you now have to generate greater lift to stay in the air. But, and here's the catch, the physical action of generating more lift intrinsically causes greater drag. And to overcome that new extra drag, your engines now have to produce greater thrust. You literally cannot touch one single variable without triggering a reaction in all the others.
Which brings us to this fantastic quote from the text that I absolutely love, and I really want you to remember this one. It says, "The structural and aerodynamic design of an aeroplane is a masterpiece of compromise. An improvement in one area frequently leads to a loss of efficiency in another." Just think about that. You want a wider fuselage so you can cram in more passengers? Well, you just added weight and drag. Now you need bigger wings and bigger engines, which guess what? Adds even more weight. Aviation engineering is the ultimate balancing act of physics, just continually chasing that perfect, efficient middle ground.
So, to wrap up this explainer, I've got a little challenge for you. The next time you're taking a trip and you look out that plane window at the clouds rolling by below, don't just see a metal tube. Ask yourself, which of these four invisible forces is winning the tug of war right at this very second? Are you climbing with lift overwhelming weight, or are you accelerating down the runway with thrust conquering drag? Understanding this battle totally transforms a simple flight into a front row seat to physics in motion. Thanks so much for learning with me today, and keep looking up.